we will see with the bandwidth. So let's start this talk on machine learning and Pharo with TensorFlow. So I guess most of you know already me. So I'm Serge Tinglish. I'm a computer scientist, and I am part of a research team called UMISCO. This team is an international research team that is a joint unit between Sorbonne University. This is the new name of the Université Pierre and Marie Curie, and IRD. So IRD is the Research Institute for Sustainable Development. First of all, before we talk about tensors and TensorFlow, I will just have a few slides about my research and where I'm currently located. So UMISCO, it's an international joint research unit, and we are working mostly on modeling and simulation of complex systems. And we are located in different places in the world. So we are located in France, but also in different African countries, like the one that you can see on the slide. So in Morocco, in Dakar, in Senegal, and in Cameroon. So I'm currently located in Cameroon. So this is why the bandwidth is sometimes a little bit difficult. And I'm in Yaoundé city. So. And there is another place where the team is located. This is in Vietnam, in Hanoi. So just a brief overview of what we are doing. We are computer scientists and mathematicians, and we are working on tools and methods that we apply on southern countries' issues. So you have 3 examples here on this slide. So we are working on sustainable development goals like good health and well-being. So the idea is to, for example, to do simulation and modeling and simulation of complex systems like the one you can find in disease transmission. So this is an epidemiological system, for example. Another topics that are very important in our team is everything related to cities, so sustainable cities. And we are working on for example, on pollution modeling. And the last example I will give you today is the fisheries. So basically what we call system ecology. I'm not working on this part, but this is also a very important issue for southern countries. So what we are doing is that we study this kind of complex system, ecological system, with mathematical and computer science approaches. And what we are doing is that we build models that represent ecological systems, and after that we can query the model, we can ask some question to the model, and we use, in fact, mathematical analysis or computer software in order to analyze these models and to predict some interesting patterns for the models. Okay, so let's jump now to the main part of this presentation, about the tensors. So, in fact, my team, we are doing lots of simulations, and what you have first of all to understand is that TensorFlow and tensors are not only related to machine learning and deep learning, but you can consider that this is a general purpose numerical computing library. So you can do simulation if you want with tensors. It's not only focused on machine learning, but it's much more general. So this is an open source software. This has been done originally by people from the Google Brain team in 2015. And most of the code of TensorFlow is written in Python and C++. And you have the C API also. And people are also using other programming languages like Java or JavaScript to use TensorFlow. What is really interesting in this library is that this is completely hardware independent. So you can run the same system on CPU or GPU, or you can mix also CPU and GPU. So it's completely hardware independent. So this is very interesting from this point of view. So you can start something on your own computer, on your own laptop. Then after that, you can deploy your system on, for example, on a cluster of GPUs very easy. So let's start with some basics about TensorFlow. Is it okay for the sound? Okay. So let's start with some basics. So I will talk about, first of all, about what are tensors. After that, because we are talking about TensorFlow, we have to put tensors in some data flows. And after we set up a data flow, we can run the data flow. So we'll talk about the runtime execution of data flows. So first of all, what are tensors? So basically, in fact, this is a very simple concept. Basically, tensors are multidimensional arrays. So you know, I guess about matrix. So it's just a generalization of matrix to to 3, 4, 5, n dimensions. In TensorFlow, there are support for lots of types. So you have different kind of floats. You have different kind of ints. You can also use tensors based on complex numbers, or booleans, or string, etc. So we have lots of diversity in terms of types that are supported. And in this, you see here on this slide, I classified the different kind of tensors depending on their ranks. So the rank is not the same as dimensions. Don't mix the two concepts. So ranks are related to the number of dimensions that you will use for one tensor. So for example, a tensor of rank 0 is a very simple mathematical concept. It's just a scalar. Okay. A tensor of rank 1 is a vector. A tensor of rank 2 is the matrix, the well-known matrix. And if you generalize, you can jump to the rank 3, and you have 3 tensors, etc. So you can manipulate in TensorFlow tensor that can be as big as you want in terms of ranks. Okay. So this is a visualization of the tensors. So the first one, the 1D tensors, the tensor of rank 1 is the set of elements. 2D tensor, so it's a matrix. After that, 3D tensors, so tensor of rank 3 is just composed of many, so it's a cube where each slice is a tensor of rank 2. And you can continue, for example, tensor of rank 4, it's just a set of cubes of, and each cube is a tensor of rank 3, etc. So this is just a way to visualize the tensor because sometimes it's a bit difficult if you have tensors that are a little bit big and with a very big rank, it's difficult to understand what the rank means. Okay, questions? No? No questions? Questions? Which chat is best for you? I guess this is the Discord one. Okay. I have no answer. I don't know if the people are following my talk or not. Hello? Is it okay for everyone? Okay, let's continue. Okay, let's continue. So, about the application, so I already say in the first slide that in fact TensorFlow is not only focused on artificial intelligence and machine learning application. In fact, you can use, every time you need to manipulate big data that are in tabular forms, if you want to do image processing, if you want to do simulation, you can use tensors and you can use TensorFlow, in fact. Tensor were first introduced in quantum physics. So it was the first application of tensors, and nowadays they are used in lots of different fields. So let's discuss now about why Pharo should take care about TensorFlow. So it's first of all, TensorFlow is a multi-platform library. So this is very interesting because you don't have to rebuild if you build the Pharo bindings for TensorFlow, you don't need to do it for the different platform. It's completely multi-platform. It's a distributed execution, so you can use CPU, GPU, you can even use TPU. So TPU is a tensor processing unit done by Google. And basically, it's a robust foundation if you want to build machine learning and deep learning frameworks, but not only. So there are already supports of TensorFlow in lots of programming languages like C++, Python, Java, etc. And so we definitely need a Pharo version to join the other programming languages. And I think it's really interesting to have support of inside Pharo about TensorFlow, because we also can reuse everything, all the tools that we are used to in Pharo, so all the live tools. And what I want to do also later is to be able to visualize the tensor more easily than in the other platforms. So I definitely think that Pharo needs to have bindings, need to have some ways to use tensors and TensorFlow. Okay, so on this slide, you have an explanation of the meaning of flow in TensorFlow, because at the moment we only talk about tensors. The flows come from data flows, in fact. So in fact, here on the left you see some nodes connected by edges. Each of the nodes are some kind of operations. So basically, them are math operations, but you have also constants initialization, and some of those nodes are also related to the logging, so you can log data by using some specific operations. So between the nodes, you have edges, and you see on this animation that you have some tensors that goes from one node to other nodes. So on the edges, you have the data. So the data are tensors. So it could be tensors of rank 0 or up to the number that you want. So you have some data that flows between the different nodes. And we will see later that data flows are defined in Pharo. And after they have been defined, you have to compile the data flows in memory to obtain a kind of TensorFlow structures in the memory. And after that, you can execute this data flow on the devices, on CPU or GPU. So this is one figures that explain the TensorFlow architecture. So basically, you have two parts. You have the core, the kernels, and the front end, the programming language front end. So the main part of TensorFlow is written in C++, and in fact, all the operations that you can apply on tensors are implemented in C++. So if you want, for example, to use the multiplication of two tensors, or if you, for example, you want to do a multiplication of two matrices, you have one operation that is called mul, and this operation is implemented in in C++, and depending of the kernels that you are using, or so if you use the CPU or GPU or something else, the operation is implemented differently. So, for example, on GPU, you will use as much as possible the performance of GPUs. So you don't have to deal with that when you use the front end. You just to say, okay, I want to use this operation, and the system. After that, you can say, okay, this operation can be deployed on the CPU or GPU, but you don't have to deal with that. Okay, so here you have two front ends, C++ and the Python front end. So most of the people are using the Python front end. But here, the idea is to add one more front end, and it would be the Pharo front end. Okay. So you see the architecture is quite simple. So if you want to build a Pharo bindings to TensorFlow, in fact, you have to use the C API layer that is provided by the TensorFlow library. So all the main functionalities of the TensorFlow are exposed through this C layer. Okay, not all the functionalities, because some of them are implemented in Python, but most of them use this C layer. So we'll use the foreign function interface and the last version of the foreign function interface in Pharo, so UFFI. And you have to study if you want to do these bindings, you have to have a look to the API. So here you have the link to the 1.8 version of the API that you need to implement. So it's not that big. It's something like maybe I don't know exactly 10 pages of text that you need to implement. So this is an example of how it works. So basically, this is the function that is called version. So I don't know if you all know about FFI and UFFI in Pharo. So here you call an external function, a C function, and you have to reuse the C API. So here in the C API, you see that the function TF version does not need any parameters and returns a pointer to a char. So you can call this function with the FFI call here, and you just have to copy the C API and adapt a little bit. Instead of char star, you have to say string, and there is no parameter. So here you have after the name of the function that is TF version, you have the list of parameters that is empty in the FFI code. Okay, and after that you say which library you want to use. So this is the TensorFlow C API that you want to use. Okay, so maybe you can try this directly in Pharo just to check that it works. Okay, so let me run the image that contains the code. Okay, here it is. I don't know if you can see the. Doesn't work. What happens? Let's do it again. Interesting. Oh, what happens? Oh, it doesn't work. Very strange. Let's try to run it again. Maybe I have one problem with the Pharo launcher. I'll quit the Pharo launcher. Pharo launcher. Okay, here it is, and it's July. Okay, this one. Very strange because the window, because I have two screens here, the window appears on the other screen, and when I change the screen, yeah, it works now. Don't know what happened. So let me copy paste this. So here we just try to query the TensorFlow library, and I just want to print the version that we use currently. So it's 1.9.0, as you can see here. It's the last version of TensorFlow. They just updated this version yesterday, so the last version is working on Pharo right now. Okay, let's try to do something more complex now. So go back to the slides. Okay. So before we start, we try to do something more complex, some explanation about the history of these bindings. So in fact, this is the fork. I didn't wrote the first version of this. This is a fork from the quiz bindings done by Javier Buroni and Gerardo Ricciarte. So they have done very nice work. And in fact, in quiz, they don't use the same FFI. So I had to adapt a little bit the FFI to the new FFI of Pharo. And I have, in fact, now this is part of the Polymath project, so you can find the code of this on GitHub. So you have the URL on the slide. And it works with the last version of TensorFlow on Mac, on Linux, and on Windows. And there is something like more than 100 green tests. And it was really a nightmare for me to port from quiz to Pharo, because I have, at the beginning, no notion about FFI, so I have to learn a little bit how it works. And the FFI between quiz and Pharo, there is a lot of differences, so it was not that easy. And it was, for weeks, it was crashing, and I didn't understand why it was crashing. And in fact, there was frankly a bug in Pharo, so I have to fix this bug. And recently, I was able to run most of the tests. It was really difficult. And I have now only finalization problems. So sometimes you have problems because some C structure are not completely free correctly. So you have still some crashes, but less than before. So basically it works, but you still have some crashes. Okay, so let's try to do something fun now. So let's try to build some sensors. So here you have some examples. So I will try this one. So basically I will create a tensor that encapsulate the number pi. So if I do something like that, here you see the tensor, and you see that this tensor is located somewhere in the memory, and you see here the value that is the number pi. Okay. So here you have to understand that because we are using a C library, every time you build tensors, they are located in the memory, in the C memory, and not in Pharo memory. So you have to need to keep references to where they are located in the memory. So this is the place in the memory where this tensor is located, and you can have access to the numbers as the Pharo numbers. If you do self as numbers, okay, you have that is the float, in fact. Okay, so after that you can manipulate more complex tensor like this one. So this is just a tensor of rank 1. Okay, so you see another tensor at different place in memory that contains these numbers. Okay, and you can build tensor of rank 2 like this one. So you just pass an array of values and you build the tensor very easily like that. Okay, so nothing fancy right now. Do we have questions? Okay, no questions. Okay, I will continue. Okay, so now we can try to do something more elaborate. So, for example, we can compute the rank of a tensor. So, for example, if I have this tensor, like this one, okay, so it's a tensor of, okay, so I can ask this tensor is rank, okay, so the rank is 1, okay, because it's, there is just, this is a set of values, so there is no dimensions, it's just a line of values, so the rank is 1. I can ask the shape, so the shape is the list of dimensions, so here we have a tensor of rank 1, and there is 3 values, so the answer is an array containing the values 3. And if I do something like that, that is a little bit more elaborate on the tensor of rank 2, so if I compute the rank, this is 2, okay, perfect. And if I compute the shape is an array of 2 and 5. It means that you have, the rank is 2, because you have 2 values here, and you have a matrix of dimension 2 by 5. Okay? So after that, do you have questions? No? So now let's try to do something about graph. So what are graphs? Graph contains a set of operations. Okay? And each operation represents 1 unit of computation. And the tensor object will, that represents the unit of data, will flow between the operations. So a graph is basically a data flow of object, and they can be serializable. And this is really interesting because you can exchange this serialization between platforms. So if you do something in Pharo, you can build a graph, data flow, and after that you can do a serialization, and you can use it in another platform, Python platform, for example. So for example, let's try to do a graph, very simple graph. So there is a class called tf graph. Okay, so I create a new graph. So when I create a new graph, okay, and I'm looking at the contents, you see there is nothing, because at the moment, okay, there is no operation. So we have built an empty graph, and we need to add the operation now on the graph. Okay. So now about the operation that we can add in the graph. So operation are node, and this is really simple. They can take between 0 and n inputs as tensors, and they can produce 0 to n tensors as outputs. So they are just black box. You give them inputs, and they produce outputs. Okay. So inside TensorFlow, you have, I don't know exactly, but maybe hundreds of operations, different operations. So you have arithmetic operators. So you can add tensors, you can multiply tensor, etc. You have mathematical function like sine or exponential, etc. You can transpose matrix, you can compute the inverse of matrix. So you have really loads of functions. After that, you can also do operation on tensor, so you can reduce the dimensions. You can, for example, if you have a tensor of rank 3, you can cut some slice inside this tensor of size of rank 3, and each slice will give you a tensor of rank 2, etc. You have hundreds and hundreds of operations that are already provided in TensorFlow. So we talk about tensors, we talk about graph, we talk about operation. Now we have to talk about how to execute a data flow. So a little bit about the runtime execution. So after you have defined the data flows that is composed with nodes inside the graph, you have to execute. So in TensorFlow, you have to build specific object that is a session, and you have to say, okay, I want to put this graph on CPU or GPU, and the session will manage the operations on the tensors. Okay, and this is completely possible to distribute the execution of the graph. And you can split the graph, the operations, the nodes on different devices. So if you have a lot of GPUs, for example, it's very interesting to split the graph on the different devices. And this is the graph is completely portable. I already talked about that. So it's completely language independent. So you can serialize the graph very easily and reuse it in another programming language. Okay, so now enough for the talk. Let's do some nice demos, except if you have some questions. Any questions? No questions? Okay, let's do some demo. So first of all, let's do a kind of hello world demo. So let's try to add 3 plus 4, so it's very simple, you see, in TensorFlow. So this is the code. So basically what we are doing is that we create a graph with TF graph create. We build 2 nodes. So we have one node that is C1 that contains the value 3 as a tensor. So it's a tensor of rank 0. And we have another node called C2. So basically these 2 nodes, C1 and C2, are constants. Okay? And so they just contain a value that will not, that is a tensor. After that, here we say, okay, I want to compute the sum C1 plus C2. So C1 plus C2, it means that we will build a new node that is the operation of addition between 2 tensors. Here the tensors are tensor of rank 0, but you can also do the same operation between tensor of rank 2, 3, 4, etc. Okay, so that's it for the data flow. And we build a new session, so we have the class TF session on this graph. And after that, we want to execute the session, so there is one method called run output. We have to say, okay, I want to have the result that is provided by the operation that is called sum, and there is only one output, that is the sum of C1 and C2, and the outputs are indexed, so the first one is the index 0. Okay, so I will run the session and obtain the result on the output 0 of the node that is called sum. And after that, I print the result as a number, as a Pharo number, and not as a tensor, because normally the result is a tensor. So I will copy paste this piece of code and try to execute inside Pharo. Okay, perfect, 7, it works. So we can have a look to the nodes. So for example, if I inspect the graph just to be convinced that these are nodes and not Pharo code, TensorFlow and not Pharo code. So I will inspect this. And you see here, I have built a specific inspector with GT tools to be able to visualize the node. So here we see that we have the two operations. This one, C1, is an operation. So you see the operation inside the memory. And C2 is another operation. And these two operations are constants, and they send their contents to this operation, the addition of two tensors. And what we are interested is we are interested by the result. So this is the output of this, the first output that we will use to print the values. Okay, so we can inspect the data flows very easily with this very simple representation. Okay. Okay, so it was the first demo. Second one, so a bit more elaborate. I want to compute do the multiplication of two matrices. Okay, I have one question from Juraj. Does sum has more outputs? Not sure. I have to check the documentation of TensorFlow, but because all operations are defined in the documentation of TensorFlow, and sometimes some operations have more than one output, but for this one, I'm not sure. I can check, but here, what is the result as number? Okay, we can try to do something like that. Okay, there is no, you see, there is the TensorFlow error that say output index too large must be less than 1. Okay. So it doesn't work for this operation, but for some operation you have more than one result. The result was displayed directly here. Sorry, I have to go back to 0 here. And when I evaluate contents, you see, yeah, it's written on the, you can inspect if you want, the values. Sorry. Here. So the result is 7, is the float. Okay, so here, what you have to understand is that I built tensor inside the memory from float values in Pharo. I built the nodes, okay? After that, everything is inside the TensorFlow memory, and I can execute this data flow. So the data flow is not inside Pharo. This is located outside Pharo. And I ask the result, and I convert with the as numbers methods, I convert the tensor that is inside the memory, that is the result, as a number, as a Pharo number. Okay? So you have to, in fact, build Pharo object and send them to the TensorFlow library, and you obtain the result at the end. Okay? So go back to my multiplication of two matrices. Maybe there are other questions. No, only Joel, do you have questions? No, that's it. Okay, so let's try to multiply two matrices. So here, okay, we copy paste the code. Paste. So what we have here, so we create a graph. So we build two tensors. But this time the tensors are matrices, T1 and T2. I put them inside nodes C1 and C2, and I do the multiplication of C1 and C2. Okay, and I build the session, I run the session, and if I execute, I obtain the multiplication. Well, I can do something like that. Okay, I obtain an array of array that contains the result of the multiplication of the two tensors. So for sure, if you want to do very simple operation like that, you don't need tensors. But you can do the same with matrices with thousands of lines and columns. and it's very, very efficient in terms of performance. So I can show you something, another example, maybe we have more example here. Okay, so yeah, this one. Oh, okay, it's slow. Okay, this one. So here, what I'm doing is that I create a graph, and I will add an operation that build a zero, a tensor of rank 3, so it's a cube of values. Okay, so a matrix of matrices, and of size 100 by 100 by 100. So it's 1 million values. Okay, and I can execute this, and okay, takes a little bit, takes some time, because in fact, what takes some time is to print the tensor. It's not do the computation. If I'm just running, it's very fast. So you see, I can manipulate millions of values very easily inside and I can have a look to the data flows. So I can do something like that. Sorry, I have to do a point here. Okay, so you see the data flow. So the data flow, there is two constants. The first one is this tensor, so 100, 100, and 100. So this is the size of the matrix. And here, the second one is 0. This is the value that will be used to initialize this tensor. Okay? And here you have the fill one, that is the operation that build this tensor completely filled by the value that we pass here. Okay, so you can see that you can very easily use TensorFlow as a general purpose computing library. You can do matrix operations on the very big matrices very easily. So now I will talk a little bit more about machine learning and deep learning, and I will give you some demos about how to use TensorFlow to build neural networks. Do we have questions before I skip to this part? Suraj, you have one question, yeah. Yeah. So what is C1? T1 is a tensor, and C1. So C1, in fact, this is an operation. It's called operation. So basically, you put a tensor inside the constant operation. Okay, because you have to initialize in some ways your data flows. So you can put variables, but you can also put constants, and you have 2 or 3 kinds of nodes like that you can use in order to initialize your data flow. So C1 is an operation that is a constant, and the previous script. Okay, this one. So C1 here is a node that represents the constant, and C2. No, it's not this one. Sorry. Now, which example you are referring to? The one about multiplication? Because here it's very simple. You have 2 tensors, T1 and T2, and two operations that are built because they just contain the tensor. Okay? And mult is another operation that is built by doing the multiplication of C1 and C2. Yeah, multiplication, yes. Okay, so let's try to continue a little bit. So inside the bindings, there are some examples that have been built by the, the people from Chris. So now it was I'm able to run some of the examples because some examples are still crashing a little bit the system. So I will. Yes, C1 is an operation. It's a node inside the graph. So what we can try to do is maybe running this example. So this is an example that we build where we build a neural network in order to do a regression on a function. So we have this kind of function. So function of x. So you see y, it's x multiplied by 10 minus 5, and the result is y multiplied by y sinus of y. Okay. So build a neural network that we will train to try to replicate the same function. In fact. So I will run the system here, and we will use Russell. So it takes some time. So here, maybe it's a little bit difficult to see here, but basically you have in red the original function, and in green here you have the prediction of the neural network. Okay, I can run it multiple times because sometimes the training is not that good. Okay. See, there's in red you have the function, and in green you have the regression done by the neural network. But here, this time it was not really good. It depends on the some initialization. Okay, so if we have a look to the code of this class regression neural network example, you will see how it works. So in fact, most of the code is composed by the initialization of the graph. Okay, so here you see when you initialize an instance of this class, you initialize a graph. So initializing the graph means that you create a new graph, and after that, you build a data flow. So here you see you can find the different layers of this neural network. So I will not talk about exactly how neural networks works, and there was already a previous talk of Alex about neural networks. So here I'm just explaining how it works from the TensorFlow point of view. So here you build different layers. Okay, 1 layer, 2 layer here, 3 layers, etc. And after that, you have to add to the data flow some ways to learn the value. So you see here the lot of operation on the tensor, etc. And so you have a lot of initialization here. So what could be interesting is that if we can have a look to the data flow. So in order to have a look to the data flow, what we will do is that we will maybe here we will do an halt somewhere, not here. Maybe we can halt here. Okay. Okay, so let's do it again. Okay. Okay, so I want to inspect. So where I am here. Okay, here. It's very slow anyway. I'm running TensorFlow and the streaming software, so what happened? Very, very slow. Okay, and I want to have a look to this one. Okay, maybe I should put an halt, not here, but after I have built the. So let's try to do. Let's try to build halt here. Okay, let's do it again. Okay, and I want to have a look inside net. Doesn't work. Yeah, because inside the object. Self. Okay. So here I have the graph. Okay, so if I'm looking to the graph, I will inspect the data flow. So this is the data flow of this neural network. So you see it's much more complex than the previous examples. Okay, so it's yeah, I have some problems on my computer. Don't know what happens. Maybe because I resized the window. Yeah, apparently it crash. It's really annoying sometimes in Pharo 7. I'm using Pharo 7 sometimes. So when you resize the window here, I don't know why it freezes completely. Okay, I will just relaunch the Pharo. Okay. Voila. And I will put an halt once again, so it was inside the example, and here, yeah, so I will put an halt here, here. Yeah, self-halt. So let's do it again. Yeah, okay, and just want to inspect this. Yeah, and the graph. Okay, and the okay. Yeah, so you see the data flow here. So it's quite complex. So you see there are lots of operations, lots of nodes, and in fact this is very difficult to debug because this is very low level, because here you see all the operations that are involved in to compute the values of the neural networks, and this is very difficult to debug. This is one of the problems that the people of TensorFlow they have. It's difficult to, when you have hundreds of or thousands of nodes, it's very difficult to debug again. Okay. So, do we have questions now? I almost finished my presentation. So, just want to show you here a tool called TensorBoard. So inside Tensor, in fact, the people of TensorFlow, they build this kind of visualization tools in order to be able to understand how data flow of operation works. So you have something like that that allows you to explore the different nodes. So at the moment, there is nothing like that. I just build something very simple, a Russell visualization, maybe you want to build something like that. But I want to have something similar to this kind of visualization tool inside Pharo. And I have one student in a master student that will work on this soon. Okay, so this is the conclusion of my talk. So this is the first version. It's no more alpha now, it's more beta than alpha. So this is the first beta version of the TensorFlow bindings available on GitHub. And you have seen that, in fact, what is really difficult when you use TensorFlow is that the data flows are not located inside Pharo. So it's very difficult to debug because they are located outside in the memory as operations on the tensors. So if you want to be able to understand how it works, you have to use something like TensorBall. But the problem with TensorBall is that it's not a lively tool. You have to, in fact, log all the events of one execution, and after that, replay all the events inside TensorBall. So I want to have something more live in order to be able to debug complex layers, neural networks. And there is another problem, is that at the moment, if you look at the data flow, it's very low level. You don't have what would be very interesting is to have something that is more close to the domain of the user. So it would be interesting to, for example, to have a visualization when you can see the layers, for example, of the neural networks, and not the tensors and the flows between the operations. There are still some crashes from time to time. The crash are due to finalization problems. It's quite difficult because every time you create a new C structure in the memory, after a while you have no more place in memory, especially when you use tensors that are very big. So you need to release the object, and it's not that easy to manage this kind of finalization. So you have to read carefully the documentation of TensorFlow, because sometimes some part of the finalization is done inside TensorFlow and some should be done inside Pharo. So it's not that easy to manage. So there's still some work in order to work on these finalization issues. Some perspectives. So we'll talk about that. I have one master's student that is working on building more complex visualization of data flows with Russell. And there are more perspectives like building a domain-specific language on top of TensorFlow bindings. Because here, if you have see the examples on neural networks, in fact, you have to do everything by combining operations. So there is nothing like Keras, for example. Keras is a more domain-specific API on top of TensorFlow that allows you to build neural networks more easily. You don't have to say, okay, if I want to have a layer like that, I have to use this operation and this operation. You just have to define the different layers and connect the layers, and that's it. Automatically, you have a data flow that is built from a Keras description, and that can be run on top of TensorFlow. What would be very interesting now is to build something like that, so something close to Keras. For Keras is only working on Python at the moment. So something close to Keras to be able to easily build machine learning and deep learning models. And I'm also interested to use TensorFlow bindings for application in my research. So you know maybe about Polymath. Polymath is a numerical library purely implemented in Pharo, and it would be nice to use TensorFlow in order to have something a bit more performant than the current version. Okay, so that's it for today. I don't know if you have questions. I don't know if there are still people following the talk. I'm not sure. Are you there? Hello? No more people? So sorry about the quality of the streaming, and the bandwidth is sometimes a little bit difficult here. So we have a question. Okay, thank you, Josh, for following me. I'm not sure there are more people than you. Do you have question? Yeah. Yeah, sure. The quality is not really good. Maybe I will do again the presentation. I will record my presentation and send it later on Facebook, on YouTube. And for the people who are coming to ESUG, I will do basically the same presentation. Thank you, Josh. Okay, so if there is no questions, maybe we can stop. Oh, I have one question on the YouTube chat. So at this moment, your operations are executed only on CPU? Okay, yes, for the moment, yes. On my computer, the operations are executed only on CPU. I have to, yeah, normally it should be not that difficult to execute the same code on GPU. I have to check, but in fact, when you build, when you create the graph, you can deploy the nodes and say, okay, this node should be run by a GPU or CPU. But you are right at the moment. It's only working on CPU. Another question? Okay, guys, so maybe we can stop here. Thank you for joining this presentation. And see you, I guess, for ESUG. Okay, thank you. See you. Bye-bye. Thank you very much.